Unit 1, test number 2, review. Lesson 5 was all about polynomials, and here are your notes and your study guide for lesson number 5. As we go through this review, please feel free to just pause the video at any time so that you can look over these sheets that are in the study guide. And go ahead and try these practice problems. For number 1, here's your hint. In order for the polynomial to have a degree of 5, that means that the highest sum of any of the term's exponents must be a 5. So if we want this first term to have a highest degree of 5, we want the exponents on those variables to add up to 5. So something plus 3 has to equal 5. On question number 2, which polynomial correctly combines the like terms and puts the polynomial in standard form? So you need to look at the polynomial right here and identify your like terms. Go ahead and combine them correctly. And then as far as putting your answer in standard form, you just want the exponents to go in decreasing order. You pick a variable to go in decreasing order. So you can say, oh, I want the x's to go in decreasing order of power, or ooh, I want the y variable to go in decreasing order of power. And as long as the terms are combined correctly, you should be able to find the correct answer choice. Here are the answers to the lesson 5 problems. The explanations for those answers are in the red and purple boxes. That's how the practice slides are going to go. Lesson number 6 was all about adding and subtracting polynomials. So here's an example of how we can add two polynomials together. Remember that in order for like terms to combine, they have to have the same variable and the same exponent. This is an addition example, and here is a subtraction example. The only difference is that when we subtract polynomials, we take this negative or this subtraction sign and distribute it to all of the second terms in the second set of parentheses. So the 7a cubed, the negative 7, and the negative 6a are going to have their signs reversed, and you can see where that step has been done right here. We distribute the negative sign or the minus sign all the way through before we combine the like terms. Here are some practice problems for lesson number 6. Your hints are in the red and purple boxes. Here are the answers to the lesson 6 practice problems. On number 1, if I wanted to find the profit of this video game company, your instructions or your hint said to subtract the revenue minus the cost. So here's where that problem is being set up right here. And then when you do the actual subtraction step, remember that you are really turning it into an addition problem. And then you're flipping the signs of everything in the second set of parentheses before you combine your like terms. And then for the second part of that example, you wanted to evaluate for x equals 1,000 because we're selling 1,000 video game systems. So I'm going to plug a 1,000 in the place of x in my answer from part number 1, and then use my order of operations to simplify. We get $2,820. Question number 2, the first part is asking us for the total perimeter of both the pool and the home. So we need to add up the 4 sides of the pool and the 4 sides of the home, and we do that by combining our like terms. When you do that, you get a total of 38x plus 10. Then the next part says, well, what happens if x equals 5? That means we are evaluating by plugging a 5 into the perimeter of each shape. So the perimeter of the pool, the perimeter of the home, we are plugging in a 5 in the place of x and using our order of operations to figure out that actual distance. And I actually have the numbers backwards in the blanks right here. The 160 yards, oh no, I have it correct on here. This one's good to go. 160 is for the home, 40 is for the pool. And I got those numbers by plugging a 5 in the place of x in each of the perimeters for each of the shapes. Lesson number 7 was all about multiplying monomials and binomials. So here are a couple of examples on how to do that. And we also have special binomial multiplication patterns. So these are the patterns for difference of squares, and then your perfect square trinomials for both addition or subtraction. And anytime we're using the variables a and b right here, it just means that that's some term. It could be a number, it could be a variable, as long as it's the same. So whatever this a position is right here, it's going to repeat in the other parentheses. Here are your practice problems for lesson number 7. And your answers for lesson number 7. Number 1 asked you which products result in a difference of squares or a perfect square trinomial. So if we're going through and we're looking for the ones that are a difference of squares, let's do that one first. Difference of squares has the form a plus b times a minus b. So I'm having two things repeated in the parentheses, and the only difference is that one set of parentheses has addition, the other set of parentheses has subtraction, and I see that the first and last choices fit that pattern. The other one that we were asked to find was a perfect square trinomial, and that takes on the form either a plus b and I'm squaring that, or a minus b and I'm squaring that. When you square a set of parentheses, you're just multiplying it times itself, and the answer choices that fit those patterns would be the second one and the fifth one. The sets of parentheses exactly repeat. That is a perfect square trinomial. Number 2 just asked you if Charisse used her algebra tiles correctly to represent her product. If we go through, let's make sure that she set it up correctly. X minus 2 times x minus 3. Along the top section, I have an x and a negative 1, negative 2. Down the side, we have x, negative 1, 2, and 3. So she did set it up correctly on the outsides. So now we just need to check her product. You go crisscross ways. So I'm going to match up this row with this column. X times x gives me x squared. And then right here, x times negative 1 does give me negative x. And I'm going to keep following the pattern. If you remember the composition notebooks that you may have used in elementary school, we had a multiplication table at the end of it, and you would take your fingers and you would trace the two numbers until they met in the table, and it would tell you their product. It's the same idea with these algebra tiles. We don't really run into an issue until we get to this section of the product right here. If I do negative 1 times negative 1, I shouldn't get negative as my answer. Negative times a negative is a positive, so that's where Charisse made her mistake. She did not multiply the negative integer tiles by the other negative integer tiles correctly. Lesson 8 was on multiplying polynomials, like longer polynomials this time, and also on simplifying our expressions. So here's an example on that you're welcome to pause, go through the color coding and trace the steps. And we also had special trinomial multiplication patterns. So just like we had difference of squares, perfect square trinomials, these are the patterns that we had for longer multiplication problems. We have the difference of cubes and the sum of cubes. When we talk about simplifying expressions, algebraic expressions can and should be simplified using your order of ops. So here's an example of how to do that, step by step. Here are the practice problems for lesson number 8. On this first question, go ahead and remember real quick that anytime you're adding terms together, we have something called the commutative property, which means you can reverse the order of things that are being added together. So like right here where it says 6 plus s, you can flip that around to be s plus 6 in all three of these choices if that helps you fit the sum of cubes pattern a little bit better. So your sum of cubes pattern should look like this. and you will need to just use the commutative property for that first set of parentheses to make it fit exactly what you're seeing on number 1. Here are the answers to lesson number 8, practice problems. Number 1, the answer was C. Your sum of cubes has the form a plus b times a squared minus ab plus b squared. So in this answer, we can say that a equals 6 and b equals s, or you can flip it. It doesn't really matter. The terms here are flipped, or you could have said that the terms here in the first parentheses are just flipped. Using that commutative property, I can reverse the order of addition. Kind of like if I said 2 plus 3, it's the same thing as 3 plus 2. I can switch the order of the addition terms in a problem and still get the same thing. So that's what happened on this answer choice right here. The order was just reversed on some of the terms. Number 2 asked you to find an expression for the area of the triangle, and it gave you the area formula. You had to plug in the base and the height into that formula. So if I do 1/2 times base times height, it looks like this, and then we're going to simplify that expression using the order of operations. There's a couple different ways that you could have started it out. You could have distributed the 1/2 through at the very beginning. I chose to multiply the binomials together first using the FOIL method. Then I distributed or multiplied through by 1/2. So my terms were 4x squared, that's where the 4 is coming from, 22x, there's the 22, and then negative 12 right here. It was just looking for those coefficients of the terms in the answers. Lesson 9 was about factoring polynomials using the greatest common factor, and we had a couple of simple steps to follow. So we asked ourselves, what is the greatest common factor of the coefficients? Then, what is the lowest exponent for each variable that shows up in all of the terms? So in our example right here, I'm going to take it one piece at a time. Let's do just the coefficients first. Those are the pink underlined items right here. And the greatest common factor of those would be negative 10. That's the most of anything I can divide out of negative 30, negative 50, and negative 70. Now I'm going to go look at it one variable at a time. Let's start with the variable x because it's the first one I see. Right here I have a power 6, power 8, power 10. The lowest power that I have for the x's is the 6. So that means that's the most I can take from all of the terms. You can't take more than what you have. So I'm going to pull that x to the 6th out as a greatest common factor and move on to my next variable. Same thing for the variable y. Here I have power 4, power 3, power 2. I'm limited by my lowest power, so that's why the y squared comes out as the greatest common factor. So the colorful piece at the beginning is your whole greatest common factor. That's what we are going to divide each term by to get our leftovers that are in blue in the parentheses. So if I take this first term, negative 30x to the 6th, y to the 4th, and I divide by negative 10x to the 6th, y squared, I am left with positive 3. The x's completely cancel, and I'm left with y squared after I divide y to the 4th by y to the 2nd. You subtract the powers on your exponents when you are dividing exponents. And you can repeat that process with the second and third terms to get your blue leftovers right here in the parentheses. Here are the practice problems for lesson number 9. I will say that question 1 has a typo in the answer choices. These were pulled from Canvas, and there is a mistake in answer choice, one of the answer choices from problem number 1. So do the best that you can on this one, and your answer might not be exact. Just match up the best choice that you can for number 1, but the rest of it should be fine. Number 2 is okay. Here are the answers to lesson number 9. Question 1, like I said, had a typo in the answer choices. What is the factored form of the polynomial 27x to the 4th y minus 43xy squared? Well, the greatest common factor of the coefficients is 1. For the x's, it's just x to the power 1, and for the y's, it would be y to the power 1. So you can see that choice A is the only one that has the correct greatest common factor pulled out to the front, but the mistake is in the leftovers in the parentheses right here. When you divide the first term by x and y, you should have x to the power of 3 left over. So I'm going to go ahead and write that in. And the y's do cancel for the first term. For the second term right here, when I divide out the x and the y, I'm left with just one of the y's, so that part is correct. But here's the typo that was in answer choice A for question number 1. There should have been a power of 3 in those leftovers for the x's on the first term. That was an oopsie from Canvas. We did not catch it in time. Number 2 is asking you to take a pentagon perimeter and divide by 5 to get the length of each side. Since it's a regular pentagon right here, that means all the sides are the same. So I can just divide the perimeter equally to get the length of each of the sides individually. So if I take 35y to the 4th minus 65x cubed and divide by 5, when I divide by a coefficient or a constant, I'm only affecting those coefficients right here, like the number parts. I'm not affecting the variables. So the answer choice D contains all the variable pieces intact, and the only thing that really changed was dividing the big numbers in the front by the number 5. Lesson number 10 was factoring the polynomials by the double grouping method. And this is just kind of the entire example of how to do that. If this is my polynomial that I'm starting with, a lot of times you can just cut it straight down the middle and say, hey, everybody on the left, you are group number 1. Everybody on the right, you are group number 2. Most of the time that will work. Sometimes you might have to switch your terms in the middle around to force things to have a common factor. So just make sure that each group has a common factor and then you're fine. I'm making this group number 1, group number 2, and I'm going to factor them individually. So group 1, I pull their greatest common factor to the front, and then I have my leftovers right here. For group number 2, their greatest common factor is 5, and their leftovers are here. We had some math magic that showed up in our leftovers. You should have a binomial that repeats itself, and we are able to factor that, the thing that repeats, factor that out on its own right here, and then we pull the greatest common factors together in their own parentheses. So here's the pattern of what double grouping makes when you do it correctly. And let's give you one to try. Go ahead and pause it and try it. You don't have to use this method that I use right here. I think it helps kind of organize the idea a little bit more, but you are welcome to just jot it down however you need to. Here's the answer for the lesson 10 practice problem. On this one, you are fine to just leave the terms in the same order that they were in. It would work either way. If you switch the order, you would still end up with something that works as well. I just went ahead and cut it straight down the middle because I saw that we did have a greatest common factor in each group. The place where you may have made a mistake, if you did not get choice B, the place where you may have made a mistake is over here in group number 2, factoring out that greatest common factor. If you only factored out a positive 3, you would have the signs reversed in your leftovers. You would have had negative x squared plus 5. And that does not exactly match what you know you're supposed to get. We know that math magic happens, and this should repeat itself. So hopefully you were able to notice that they were different. Go back and factor out a negative to flip the signs where you need the signs to be flipped. And I do carry the sign with me in my greatest common factor. So right here I have the minus 3 in this parentheses to match the negative 3 that I factored out of group number 2. If you wanted to check any of these answers, since this one is multiple choice, you could technically just go back and FOIL out all of these answer choices and see which one gives you what you started with. That's another method that you could use. The last lesson for this test was about factoring polynomials when the first coefficient is a 1. So here's an example of a trinomial that looks like that. The number up in front of the x squared is an invisible understood 1. We do not have to write it down. So I have x squared plus 6x plus 8. And the really cool pattern that we're trying to fit when we factor ones like this is we need to come up with some numbers that complete 2 jobs. we need numbers that can multiply to make 8 and add to make 6. And the reason I'm saying 8 and 6 is because those are the number parts of the problem down here. I want to multiply to make the constant, and I want to add to make the middle coefficient. So I want to be able to write my answer in factored form as two binomials like this, x plus something times x plus something else, and I have to figure out what goes in these positions right here. The 2 and the 4 are initially blank spots, and you have to fill those in yourself. We're going to start by factoring. I think that's the easiest. First step is to go ahead and factor the number that you're trying to multiply to make. We're trying to multiply to make the number 8. So I can do that in a couple of ways. I can do 1 times 8 or 2 times 4. You can also do the negatives of those, -1 times -8, -2 times -4. But for this problem, since everything's positive, I just did not list those. And then I want the combination of factors that also adds up to give me 6. 2 plus 4 is the only one here that adds up to give me 6. So I know that the numbers 2 and 4 are going to fill in my blanks in my binomials. And if you wanted to FOIL this back out and check it, you will get exactly what we started with at the beginning. Go ahead and try this one. Don't forget to read your hints. And here are the answers to lesson 11 practice problems. Number 1, you're looking for numbers that multiply to make 8 and add to make positive 9. Those numbers would be 1 and 8. So choice A has the correct numbers in the binomials. Then number 2 is just asking you to interpret the algebra tiles real quick and make sure that you know how they're supposed to look. Your hint said that you want them to make a perfect rectangle in the product space. If you look at choice B, we have a gap right here. There's also a gap over here in choice C, and we have quite a few gaps over here in the last answer choice. The only answer choice that has everything in a nice, neat, tight rectangle would be this one right here. Another way that you can go through and check is just make sure that a lot of the multiplication is done correctly. There are multiple mistakes that you can be checking for in the algebra tiles. If you prefer to just FOIL things out by hand, you can also try it that way. If you know how to factor this trinomial, you would know that it would be x minus 2 times x minus 3. You can also just look for the algebra tiles that have those set up as the factors along the outsides, x minus 2 and x minus 3.